Okay, so let's talk about solving systems of equations by elimination now. So I have another system that I've written here, and we're going to solve this via the process of elimination. We're going to stop at one point and talk about why certain things are illegal, because I think a lot of times you're taught elimination, but you're not taught necessarily why it works. So I've got this system, and the first thing I'm going to do is I'm going to choose a variable to eliminate. Now it could be either the x or the y, does not matter. I'm going to choose to eliminate the x's here. And the way I'm going to eliminate that is I'm going to take each equation and multiply it by a constant to make those variables' coefficients comparable. Now when I look at this, see what I did here. I multiplied this top equation by 5 and the bottom equation by -2, because I like to make, when I'm doing elimination, I like my coefficients to be the same number but opposite signs. That way when I go to combine the equations, I can add them together. You could just go ahead and make them the exact same thing, but you'd have to subtract. No big deal either way. So I multiply this top equation by 5, and that gives me 10x plus 15y equals 70. By the way, perfectly legal to multiply both sides of an equation by a number, right? You don't have to do it to the other equation because it's a different equation. So in the bottom equation, I'm going to multiply that one by -2. And as long as I multiply all the individual terms by -2, I'm in good stead. All right, so now I've got these two equations, and those coefficients on the x's are comparable. So now what I'm going to do is I'm going to add and subtract the two equations to eliminate that variable I chose. Now, this is the step that's a little weird, because people are like, how can you add two equations together? All right, so you've got an equation, and you know from like pre-algebra and algebra 1 that it's perfectly legal to add or subtract the same thing from both sides of an equation. If I wanted to, I could add a 5 to both sides, or I could subtract 6x from both sides. It just so happens in this case, instead of adding like one quantity to both sides of an equation, instead I'm adding two quantities that are equivalent of each other. So this equation right here says that -10x plus 14y equals 46. So if I add -10x plus 14y to one side of the equation and 46 to the other side of the equation, I'm actually adding the same thing to both sides of the equation because they're equivalent. All right, so when I add these two equations together, the x's would go away because -10x plus 10x is 0. And then the y's add together, they give you 29y. And the z, there's no z's, the constants are 70 plus 46, that's 116. So now I have an equation that just has y in it. I can easily solve that for y. Y ends up being 4. Now, just as in substitution, we're going to take that number now and plug it into any of the previous equations to find the other value in the solution. So I'm going to take that y, I'm going to choose to plug it into the top equation, this one, and when I do that, here's the arithmetic, and I get that x equals 1. And again, the solution is the point 1, 4. So that's elimination.